So I wanted to have an easy way of recording machining videos on my mill, and setting up a camera every time I wanted to record something was getting rather tiring. So I decided to build and mount an IP camera directly on the machine. I'm using a Raspberry Pi 02W and a cheap camera module, as well as a small LED ring I soldered together. The LED ring comprises 3 sections, each of which is controlled by a single GPIO pin, allowing me to set 3 brightness levels for the light. The entire housing was 3D printed in PETG with some TPU interfaces. Some small screws were used to hold the Pi and LED transistor/resistor board to the housing, and the housing is held together with M3 bolts and threaded inserts. I also added a small lens protector for the camera. This was cut from an acetate sheet and will be quite easy to replace in case it gets damaged by chips from the machine. This is the camera installed in the machine. It clamps onto this part of the DRO so as to travel with the head while staying relatively out of the way and in an area that should be mostly free from chips. The power cable has this nice on-off toggle switch. I've just taped it in place for now, but later on I think I'll make some magnetic clips to hold it down. Now, with all of that said, let's get into how I actually made the camera. I won't really go over the hardware since that stuff is pretty easy to do, and unless you want to perfectly replicate my setup, you'll just need to make your own versions anyway. Instead, I will focus on the software and scripts I used for this. The first thing to do is flashing the OS onto the SD card. Here, I chose the device, which is a Raspberry Pi 02W. Then, I choose the OS. Since the software I'm going to use requires an older version of the OS, I have it saved on my computer and I pull it up here. Then, I select the SD card as the storage device. Finally, I'll check the configuration settings. Since I've done this before, they're all pre-filled with my desired settings, but if this is your first time setting this up, you might want to change them. Once that's all done, then we can go ahead and click Yes to actually flash the card. So now that the OS has been flashed and the Pi is connected to power, I can SSH into it. Oops, forgot to clear this after testing an earlier version. Okay, so now I can SSH into the Pi. And the first thing I'll do is edit the config file so that on boot it will automatically set the GPIO pins I'll be using to low outputs. Next, I'll use the raspi config command to enable legacy camera support. And with that done, I'll reboot the Pi before proceeding to the next step. Okay, and now that we've connected again, I'll just start with the sudo apt-get update. It's a pretty standard command for Raspberry Pi. Now this and the sudo apt-get dist upgrade that I'll do next, I've already done on this installation, so they'll complete faster than they normally otherwise would, but I still just want to show the process here. And then now we install Git. And now we clone the Git repository for the rpicam web interface. Now from here, we change directories into the rpycam web interface folder that was created when we cloned the Git repository. And from here, we simply run the install script. Now I'll navigate to the macros subdirectory. This is where the scripts that run off the web interface buttons are located. From here, I'll use the nanotext editor to create the slideup.sh file. I've already written the script out in Notepad, so I'll just copy-paste it here. Then I'll do the same for lightdown.sh. These scripts change the light value up or down and track the current value by storing it in a text file called lightstate, so I'll need to create that file next. Okay, and now that the relevant files have been created, I'll need to give them proper permissions in order to get used correctly. First, I give execution permission to the shell scripts. Then, I give write permission to lightstate. Finally, I add the user www-data to the GPIO group. Now, I go back up a directory and open the user buttons D file. I'll modify this file to create two custom user buttons, light minus and light plus, that will run the light down and light up scripts respectively when pressed. When I save the file, I remove the D at the end. And now, all that's left is to reboot the Pi. And now we'll just briefly go back to the lightstate permissions because I didn't set them up correctly. So the command you actually need to use is sudo chmod o+w, and that gives other users the ability to write to the lightstate file. Double checking that, I see that now the permissions have been set correctly. So I'll go over to the browser where I've loaded up the web page. And there's the interface. We can see the light plus and light minus buttons, and when I click them, they'll go through the full cycle. Repositioning the camera, so that should make it a little bit easier to see. And there we go. So, with everything working as intended, now it's time to install the camera on the mill. So this is the web interface page for the camera. When I click on HTML, that takes me to the actual camera itself. So here I can see the live feed from the camera pointed at the mill. And in addition to the light minus and light plus buttons that we added earlier, it has all of these others. So we can start recording video and then stop. We can take a picture. And we can start a time lapse or motion detection. And we can also just stop the camera and restart it again from here. Then we have a couple different settings pages. So for the camera settings, the annotation, that's what's shown up here. I don't really like that, so I'm just going to get rid of it. And there we go. Then the other one that I'll change is the rotation. So I'll set it to 180 degrees. And there we can see now that the mill table on the vise is positioned correctly. And that's all of the actual camera settings that I'm really going to change. But there's all this other stuff available. We have motion settings as well. I'm not going to mess around with those. And system. So I can access this from any device connected to the network. So on my phone, I can start and stop recording videos and then download them onto my computer. So for the download, I'll just go to download videos and images, and I can see them here. So this right there is the picture that I took. This is the video.
I can go and play it. Not really showing much since I'm not doing anything at the moment, but that's what that looks like. And I can download them, I can delete them, I can manage what's stored on the camera from here. So I'll delete those since they aren't really doing anything. And now the last thing to do is I'll actually record myself making some cuts on the machine. Okay, so now here I am doing some basic cuts on the mill. I have sped the video up. It's running at about 5 times speed right now. And unfortunately, the camera doesn't record sound. That is one of the major disappointments of this. The other being that the LED ring doesn't quite work as it's supposed to. It seems for some reason to not be getting enough power. Not totally sure why that is, although I suspect it has something to do from the fact that they're receiving power through the 5-volt supply from the Raspberry Pi. I had hoped that that would be enough, but seemingly it isn't. At some point, maybe I will redo the project, and if I do, I will focus on adding sound and changing the power for the LED ring so that I actually get proper illumination.